Guys, good morning. So we are starting the new lesson, right? The kinetic chemistry. Yeah. So this is something about the rate of reaction. Yeah. So now we discussed and we finished the last lesson, the thermodynamics. Yeah. And I gave you the question bank 2. And yeah, correct. Very good. Right. So the question bank 2 AK. Now, if you like put me a text message if you haven't received the question bank 2. I gave you few more tudes. I gave you the question bank 2. What else? Only question bank 2? No. I gave another tude, didn't I? Elasticity dunne? So I suppose to send you the elasticity lesson, one of the physics lessons, and the electricity, and the question bank 2. So I think they are there, right? And the question bank 2 I did this morning, but I wasn't home to take it. I'll take it later from the post office. Good. So it has received. Yeah, good thing, right? It has received. Then yeah, so start doing the questions in the question bank as well, and keep a follow up on all the questions, and we'll be doing more in the upcoming days, and you'll be having a separate a paper class, right? Be having a separate paper class most probably on Friday, one of the Fridays, and yeah, so you'll be doing more questions and received shiny. Good. It's a very good thing that you are receiving tudes early, because I was really worried, because like in the previous days I couldn't. Yeah, yes, so it's a good thing you have the tudes, right? Shall we start then? Kinetic chemistry. Where is this Diana? It's getting late. Doesn't matter. She'll come slowly. Let's start. Kinetic chemistry. So kinetic chemistry is simply something about the rate of reaction or the speed of a reaction, how fast a reaction can occur. And does it matter, the rate of like, would you think should it be always fast or should it be always slow? It should be in a ambient level. It should be in a ambient or a proximal level of rate. Yes, because when it comes to the rate of reaction, it's not like the people sometimes think that the rate of reaction should be fast, so they can make the products really fast. Yeah, so it's not, doesn't happen the same way all the time. Yes, depending on the chemical process, you have to align the things and to get the best yield out of it in the minimum time that is possible. That is how we do. And let's say like if it is an exothermic reaction, which means over the reaction, the forward reaction produces heat. Now think of a reaction that happens fast and exothermic. What would happen? The heat will accumulate, right? The forward reaction is heat releasing, the heat will accumulate really fast, so that will be explosion, isn't it? So all the reaction doesn't have to be fast all the time. It's not the whole point isn't about speeding up. It's about making it to a proximal level, that is giving the best yield during the minimum period that is possible, and the quality can't be altered, and the reactants and the materials shouldn't be wasted. That is the whole point. So in an industry, this rate of reaction is very much important, and there's certain different scientists who do the research on the reaction, and depending on the research result, they make the complete process of reaction. You call it the chemical processing scientist, or it's sort of an engineering thing as well, chemical processing engineering. So they make the process, how much of a pressure should be there, how much of a temperature should be there, what time should you take it out, what time should you put it into the chamber, sort of everything they decide it by doing the experiments, and it's a huge process. and those huge processes becomes huge industries like the chemical industries, right? So rate of reaction is a very small part of that, very small part of that. Learning much more when you go to the universities and you need to do the higher studies, you know. So it's a very small part of a very big thing, right? Now, so rate of reaction, we will have to calculate it to find the value, you know, the rate, right? How fast can it happen, and how do you calculate the speed of that reaction is the first question. So how do you calculate the rate of reaction? If you are to calculate now, your reaction is given for you, one of a reaction is happening, let's say two of the reactants are reacting, right? Two of the reactants are reacting, and let's say A plus B are reacting, right? A plus B are reacting and produces C, yes? So now this is the reaction given for you. How would you find the rate of this? How would you find the speed that it occurs? Any idea? Any of the online people, how do you find the rate of reaction if this reaction occurs? Yeah, yes, you have to, at the end you have to divide it by the time to get the rate or the speed. Yeah, time is always there. And what do you divide by the time? That is the question. What can you use to calculate the rate or the speed in a reaction? What happens to the reactants when you are එතකොට reactants වල මොනවාද ගන්න? The reactants becomes products, so the reactants are decaying or reducing in amount, yes, and the products are increasing in amount, or the products are producing, yes. So we have to have the amounts, the values, right? So either one way you can take the amount of reactants reacting in a certain period of time, that gives a rate, isn't it? That is the rate of reaction as well, the amount of reactants reacting within a certain period of time. That is one way of doing it. The other way is what? The other way is the products. We can calculate the amount of product produced, can we? We can, right? We can calculate the amount of C produced within a certain period of time. That is the rate of production. This is the rate of consumption. This is used. This is produced. So the rate of consumption of reactants and the rate of production of the rate of production of products. Yes. So using those two ways, you can calculate the rate of a reaction. That is simple as that, right? And now there are many things when it comes to the consideration. That was the simplest, you know, the definition or the explanation I can give. You just calculate the rate of reaction using either the reactants consumed within a certain period of time or the products produced within a certain period of time. But it's not that simple when it comes to the, you know, the much more theory and the calculation, because it changes. Now one of the misconceptions the people are thinking is that, so do you think that rate of reaction of these two of the reactants and the product, if I calculate it using the reactants, you are getting a rate of reaction, let's say a value x you are getting, right? And again you are calculating the amount of product or the rate of product produced in the same reaction in the same period of time, and you are getting a value. Do you think that rate of consumption of that reaction and the rate of production of the same reaction should be equal? Do you think should it be equal all the time? It's actually not. but there's a misconception that like the people think that the rate of reaction of consumption or the rate of rate of reactants are reacting and the rate of products are producing are equal. It's not, right? That is one of the misconceptions. It's not equal. No, there is no. There's a reason why it changed. We'll discuss it, right? So the one thing that I have to tell you is it's not equal all the time. Sometimes it's equal, yes, but it's not equal all the time. Rate of consumption and the rate of production don't have to be equal all the time. Yes, they change depending on something. We'll discuss it, right? Right. So first, before that, we have to calculate it. How do I calculate the rate of reaction? So one is the consumption and the production. Yes. So if I come to the consumption, right? Consumption of the reactants. That is, we have to calculate it using the final amount of reactants minus the initial amount of reactants. It's something like this, right? Let's say initially, right? Let's say initially there is 1 mole of A and 1 mole of B. Yeah. Holy cow. මං හිතන්නේ දාන්න පොඩ්ඩක් ස්විං එකට ගන්න. Hey guys, did you miss any of the parts I was telling? Malshi, Shanal, Shiny, can you tell which part did you miss? We came to the here like initial amounts of A and B and the C final producing the final product. Did you miss that part or you heard it? Missed the whole thing? From which part? We only discussed this. We didn't come to this part yet. Like we were discussing how to calculate the rate of reaction. Yes. Using 2 of the ways. What are the 2 of the ways? Oh. Right. Hari, misconception again. Alright. So we were discussing, about the rate of reaction, right? So the rate of reaction is something reacting in some sort of a speed, and we supposed to calculate the speed. And it's important when it comes to the industries, because you have to know the rate of reaction, you have to handle the rate of reaction as well, right? So simply we discussed that rate of reaction we can calculate it using 2 ways. One is the rate of consumption of the reactants, how much of reactants you are consuming in a certain period of time, right? Consumption of the reactants, right? Consumption of A and B, the rate of consumption of A and B, right? And or else you can calculate the rate of reaction using the products produced. Yeah, how do you calculate it using the products produced? The amount of products produced within a certain period of time. So it's simple as that. So only two of the ways are there. One is depending on the reactants, the amount of reactants consumed in a certain period of time, or amount of products produced in a certain period of time. That's all, right? Simple as that. And we discussed that the rate of consumption of reactants and the rate of production of products doesn't have to be equal all the time, you know. And there is a misconception, and even I, you know, thought the same, that the rate of consumption and the rate of production should be equal in rate. I was thinking like that, but it's actually not. Do you understand that part? Yeah. So people think that it should be equal when it comes to the reactions, you know, but it's not all the, like, it's not equal all the time. It changes.
Both the sides have to be equal, that's all.
Yeah, both the production and consumption are not equal all the time. Sometimes it's equal, but in most of the cases it's not. It's changed. We'll discuss why it changed, right? So now this is the thing. So I'm taking the initial amounts, right? Initial amounts of A is 1 mole and the B is also 1 mole. So none of the C is produced, right? So that's 0 at the initial. And in the reaction, you know, in the reaction, what happens is 1 mole of B is reacting with 1 mole of A. And how much of C is supposed to be producing? 1 mole of B is reacting with 1 mole of A, and how much of C is supposed to be produced? 1 mole, right? There is 1, because only one is reacting with another one and is producing another 1, right? That's all what happens. The Zoom is completely, yeah, I think it's English. Oh, this. Hey. Why? Why on earth that happens? I don't know. Malay. Signal router එකේ සෑද මල්ලි? නම් එක අනුව මේ Nobody's there. අර link එක මත open කරේ. How's birth education? Same, right? I'll start. මල්ලි චුට්ටක් වාට ළඟපාත ඉන්න වෙනවා හැබැයි. මේක අර off වුණොතින් අපිට අප ඒ මිනිත්ෙන් we will continue this way the class only again you joined. So we'll continue the class this way and I have to give the recording. Right? Not a nice thing but what to do. Right? So I can't even tell it to them. It's not nice. With the recording. Okay. So anyways, right. Now this is how the reaction occurs, right? So we were discussing the initial amounts are 1 and 1 and initially none of the products are produced. And in the reaction, 1 mole of B is reacting with 1 mole of A and 1 mole of C is supposed to be produced. And that happens because the ratio between A, B, C are 1:1:1. That this can change, you know. This ratio can change. We call that the stoichiometry. Call it the stoichiometry. Stoichiometry can change. So when the stoichiometry change, the amount of the reactants react and the amount of products producing will also change. Right? That is something you have to understand. So as like beginning, I'll take the 1:1:1 ratio. It will be simple. So 1 mole of A is reacting and 1 mole of B is reacting and 1 mole of C is produced. So at the end, the final, complete A has reacted, so no A left. Complete B has reacted, so no B left. And complete 1 mole of C has produced. Yes. So that is how the reaction occurs, right? And so now if I ask you to find the rate of reaction using these two of the reactants and one of the products, this is how you do it. So if you are asked to find the rate of reaction using the rate of consumption of A, right? Rate of consumption of A, that will be RA, rate of consumption of A, should equal to final amount of A, right? Final amount of A minus initial amount of A, right? Initial amount of A divided by the time spent, right? The time spent. Get it? And if you are asked to find the rate of reaction of B, right? Rate of reaction of B, that will be RB equals final amount of B minus initial amount of B divided by the complete time spent, right? Complete time spent. Yeah. And if I ask you to find the rate of reaction of C, that will be RC and that will be final amount of C minus initial amount of C divided by the time spent, right? Now this is the formal basic formula, right? Final minus initial divided by time. That's it, right? And if I applied the values, there is something that will happen here. You have to see that. Now tell me, if I apply the value here, what will happen? Right? So if I apply the values here, this is something can happen. Now tell me the final amount of A, that is 0. Final amount of A is 0. So it's RA equals final amount is 0 minus what is the initial amount of A, that is 1. We will take the time spent as 1 second, right, 1 second, and I will take this as mole, it's moles, and the rate of reaction is what? Zero minus 1 over 1, that is really what 1? Minus 1 minus 1 moles per second, right? Now don't think that these are like very deep and hard things, it's not, right? It's simple, very simple as you see it, ne? So it's minus 0 minus 1, that is minus 1, divide by 1, that is minus 1 moles per second, and the difference here is there is a minus value, ne? There is a minus value. So why is it minus? Because you always have to take the final minus initial, right? You have to take the final minus initial, the amount that is reacting or producing. You have to always take the final minus initial. So if you consider the reactance, get my point, if you consider the reactance, always the final amount is less, initial amount is more in the reactance, because the reactants are reacting and their values are reducing, ne? So the final minus initial of the reactants are always a minus value, isn't it? So if you get a minus value in the rate of reaction, there is a rate of consumption, not a rate of production, right? It's a rate of consumption. So if the rate of reaction is a minus value, then it's supposed to be a rate of consumption. Get it? And because of that, when you are writing the rate of consumption formula, you have to put a minus value in the front. Why do you put a minus value in the front? To make the minus answer a plus, right? So you have to convert the minus value into a plus, because you don't write the rate of reaction in minus, you know. So to convert it into a plus back again, you are applying a minus in the front of the rate of reaction formula of rate of consumption. When it comes to the rate of consumption, in the front you have to apply a minus, right, for the formula, right? Right. And it will be same for the RB. If I consider RB, what is the final amount of B? There is that is also 0. Initial is 1 mole, and the time spent is 1 second. So the rate of reaction back again is minus 1, right? And the RC, what is the final amount? That is 1. And the initial amount? No, the initial amount is 0. None of the products were produced. 0. Divide by 1, and it gives a rate of 1 mole per second, right? It gives a rate of 1 mole per second. So it's a plus value, isn't it? It's a plus value. So if it is a plus value, the rate of reaction is a rate of production, and you don't have to put any of the minuses in that formula, right? So if it is a plus value, it's a rate of production. If it is a minus value, it's a rate of consumption. That is one thing you're supposed to know, right? And the formula is always final minus initial, right? Right. Understood up to now? That is so far enough for now, right? Right. So the reactants and the results of the products, right? 2A plus B is reacting and producing C plus D, right? And rate of consumption of like there are two ways to measure the rate of reaction. That is rate of consumption of reactants and the rate of product formation, right? So these are the two ways of measuring the rate of reaction, either using the consumption or the formation, right? Right. So if we write it based on the number of moles and the based on concentration, right? So when you are calculating the rate of reaction, there are two major ways, like major units that you are using. One is you measure the amount using moles. The other way is you measure the amount using concentrations, right? And usually the standard is using the concentration, but in some of the cases they are using number of moles as well, right? And in some cases they can use the number of grams as well, doesn't matter. Yeah, number of grams, the change of mass, even you can use that doesn't matter, right? But usually what they use is either the number of moles or the concentration, right? And the standard is concentration, right? The standard is concentration, right? So now based on number of moles and based on the concentration, we have to write the formulas that to calculate the rate of reaction, right? So shall we we will write it in the usual terms, so it's always final minus initial, right? And take a sticky note on that. This part, you take a sticky note on that, right? Values ටික ඕනනම් මෙහෙම දාලා ලියන්න. ලියලා ඔය මෙතන රියැක්ෂන් එක උඩින් ලියන්න. ඊට පස්සේ මම අරකේ ස්ටෑන්ඩඩ් ෆෝම් එකට ලියන විදිහ කියලා දෙන්නම්. හරිද? මෙන්න මෙතනින් මේ හරියෙන් අලවන්නකො. මේ හරියෙන් හරි මේ පැත්තෙන් අලව ස්ටිකි නෝට් එක ලියලා. ඒක දාගන්න නෝට් එක. ඊට පස්සේ අපි දැන් මේක ඒ කියන්නේ ඔයා පේපර් එකේ ආන්සර් කරනකොට ලියන ස්ටෑන්ඩඩ් ෆෝම් එක මේක නෙමෙයි. හොඳේ? මෙහෙම මේ වචන උච්චර ගොඩක් ලියන්න ඕනේ නෑ. You don't have to write everything, but this is the basic. මේ basic එක ගන්න ඕක sticky note එක ලියලා අලවල තියාගන්න. But you don't have to write this in the answer script, right? You don't have to answer it this way, just for the knowledge. මේක ටග් ගාස් sticky note එකක් දාගන්න. Finish. Finish. Quickly, don't take time. ये तो रहा वार्म अप पे के भाई हूँ हमने लिया online people, are you finished? Kinetic, Malshi, Chanel, Shiny. Finish. Yes, finish. Going to the next one. Yeah, finish. Now they are all finished. And they are online. Yeah, finish. Right. So that is the rate of reaction, right? And now this is how you write it, right? Right. So if it is based on the number of moles, this is the formula you use, right? So if it is based on the number of moles, this will be the reaction, right? R equals, now this is based on the product, right? First one is based on the product. So the product doesn't have to have a minus in the front because it's a plus value anyways, right? So delta, the number of moles, right? That will be delta n, right? Delta n. So if I write it depending on the C product, right? I am considering the production of C. So if I consider the C, I'll take it as RC equals the NC, right? Delta N C, or the initial, sorry, final minus initial amount of C divided by delta T, supposed to be the formula, right? This is the format that you write it. That is the time difference, and this is the molar difference, final minus initial, and this is the time difference. Maybe you are taking like sometimes you are taking the time from the middle, from the 4th second to 10th second, so you have to take the difference. Likewise, this is time difference anyways, like, yeah, it's the time difference, the gap, right? So it's a delta. And if you consider the same based on the concentration, this is how you write it. The rate of production of C is equal to delta concentration. You write it like this, like a block bracket, right? This type of C. This is concentration difference of C. If you write it in like a block like this, it's a concentration. That is what it means, right? This means the concentration. Yeah, that's a bracket, right? Yeah. So that's a concentration, right? And divide by delta T. That is the rate of production of C considering the concentration, right? Are they trying to blow the whole thing, or I don't know? Right, by the reactants, right? If I consider one of the reactants, which should I consider? If I consider A or if I consider B, it will be same. I'll consider A. Okay, I'll consider A. So if I consider A, that will be R A. And should there be a minus in the front? Should there be a minus in the front? Yes, because it's the reactants, right? If it is the reactants, you have to put a minus in the front, delta the number of the difference of number of moles of A, right, or the consumption of number of moles of A, divide by the time spent, the delta T, right. This is the rate of reaction of A. And if I consider the rate of reaction of A depending on the concentration, that will be Ra equals, how do you write the concentration? This bracket, right, the square bracket, right. You have to put a minus in the front, delta A divided by delta T, that is the format. මේ තියෙන්නේ reactants වලින්, මේ තියෙන්නේ products වලින්, මේ තියෙන්නේ moles වලින් ලියන විදිහ, මේ තියෙන්නේ concentration වලින්. That's all. Understood it? Right. Write it down. Oh. ඒ තමයි reactant එක වර්ගය. නෑ. I said the product C. That's the product C. Right? This means the rate of production of C. Right? This means the both means the rate of production of C in the means of moles, in the means of concentration. That's all. Yeah. So you have to know how to write the formula. This is the basic formula. And remember to put the minus in the front if it is reactants, right? If it is consumption of reactants, always put the minus in the front, right? Finish? This is A. Finish? Yeah. Right. So this is the two of the formulas, right? R equals delta N over delta T. R equals delta the concentration difference over the time, right? The definitions are there, right? ඒ කියන්නේ දැන් ඔව් ඔව් එතකොට ඔයා හොයන්නේ rate of formation of A ඒ වගේ එකක් නැත්නම් rate of consumption of A rate of consumption of B N means number of moles there like ඒ කියන්නේ concentration එකට අපි නිකන් N කියලා දාලා තින්නේ අතොරට just me symbol yeah so the square bracket means the concentration that's all you have to know right so this is the the basic formulas you have to remember those two yeah right the stoichiometry of a reaction determines the ratio of the number of moles of reactants react and the number of moles of products formed. This is you already know. Yes, the stoichiometry of the ratio of the reactants and the products that are formed. Yes, right. So depending on the stoichiometry, right? Depending on the stoichiometry, the rates can be changed, right? Rates can be changed. So if I consider something like this. This is 1:, okay. Now I'll consider the stoichiometry of A is 2 and the stoichiometry of C is also 2, right? So this is what it says. Sample question: if only 0.5 moles of B reacts with 1 mole of A plus B present, write down the amount of products C and D formed and the final amount, right? And this is the stoichiometry, right? So depending on the stoichiometry you have to find what are the amounts that are reacting and what are the amounts of products that are producing, right? So if I consider here 0.5 like 1 mole of B is there in the beginning and 1 mole of A is there in the beginning, but only 0.5 is reacting of B, right? And how much is reacting of A? 0.5 mole of B is reacting and you have to find how much of A is reacting. How do you find it? That is depending on the stoichiometry. So B to A ratio is 1:2 because there is 2 in the front. That is 2A. That is the amount. This is the amount. Yeah, no, like A වලින් තියන්නේ 1 mole. හරි. හැබැයි the ratio that it react is 2 to 1. Right? That is the ratio. ඒ කියන්නේ එකකට දෙකක් set වෙන්න ඕන. එකක් එක react කරන දෙන්නෙක් ඕන. That is the ratio that they react. But the amounts that are available are 1 and 1, right? So now tell me what happens. Like 0.5 of the B is reacting. How much of A should react with 0.5? If it is 1 to 2, how much should react? 0.5 to 1 should react. Get it? So it reacts 1 mole of A with 0.5 mole of B. That is what you call the stoichiometry. Do you get it? Because when the stoichiometry changes, the amounts that reacts are also changing and that affects the rate of reaction as well. We'll come to that point, right? For now, do you understand when the stoichiometry changes, the amounts that react are also changing depending on the stoichiometry. So if it is 1 to 2 with 0.5, it has to react 1 mole of A, right? So 1 mole of A is reacting, right? And how much of C supposed to be produced? 1. Why? Because the stoichiometry is 2 to 2, right? And if you consider 1 mole is reacting of A and if it is 2 to 2, which means 1 to 1. So if it is 1 mole reacting, 1 mole should be producing, and that is if you compare the A and C. But if you compare the B and C, that is 1 to 2. 0.5 is reacting. How much should produce? 1. It's the same answer, isn't it? So it doesn't matter. You take whichever the reactant you take, or whichever the product you take, compare the stoichiometry, two of the stoichiometries, you get the same values, right? You can compare any of the reactants and the products, compare the stoichiometries, you will have the same values for all, right? So if you compare the A and C, it will give a 1 mole, and if you compare the B and C, it will give the same. So the stoichiometry gives the same values compared to any of the reactants and products, right? So now tell me the D values comparing to the A. How much is reacting? 1, and the stoichiometry is 2 to 1. So 1 to 0.5. So compare the B. 1 to 1. 0.5 is reacting. How much supposed to produce? That is how it happens. That is how the stoichiometry works. Did you understood? Yeah, good, very good. So the final. So like complete 1 mole is reacted. So what is left here? 0 left here. Nothing is there. Only 0.5 is acting here. 0.5 is left, right? And here 1 mole produced. Here 0.5 mole produced. Get it? Now in this case, do you see that B is retained or B is left without reacting? Yes, and that is an incomplete reaction. Get it? It's an incomplete reaction because one of the reactants became what? Limiting. Get it? One of the reactants became limiting. It was limited. So one was left without reacting. If it is a combustion, like in the engines, like the petrol reacting with oxygen, if all the petrol molecules aren't reacting with oxygen and non-reacted petrol particles are going to the atmosphere, you call it what? It's an incomplete combustion, right? It's an incomplete combustion. That is what you check in the yeah, and මේවා check කරන emission එක වාහනවල දුමක් යන්නේ සුදු පාට. That is what? That is that incomplete combustion. ඒ කියන්නේ එක්කෙනෙක් මොනවා වෙනවද? limit වෙනවා. එක oxygen limit වෙනවා. ගොඩක් කාට oxygen limit වෙනවා වගේ එකක් තමයි වෙන්නේ. හරි. එතකොට මේකත් ඒ වගේ incomplete reaction එකක්. The reaction isn't complete, right? One is becoming limited. Get it? Now tell me which one became limited? B is excess. A became limited, isn't it? Because the limited one is reacting completely and the other becomes, yeah. So this is the one is limiting. It's limited amount. This is extra. මේක මදි වෙනවා. එයා ලිමිට් වෙනවා. එහෙම මෙයා පුලි ඉවර කරන්න මෙයා ලිමිට් වෙනවා. පුලි ඉවර කරන්න බෑ. මෙයා ලිමිට් වෙනවා. මෙයා ඉතුරු වෙනවා ඒකින්ද. This is the limiting factor නේ. අර දෙන්නෙක්ට කන්න තුනක් ගෙනාවා වගේ. එතකොට දෙකයි අපි හිතමු එක්කෙනෙක් කන්නේ එක්කෙනෙක්ට කන්න පුළුවන් එකයි කියලා. එතකොට තුනක් තියෙනවා කෑම කන්නේ දෙන්නයි. So one is left without eating නේ. Like that. එතකොට එකක් retain වෙනවා. එතකොට තව එක්කෙනෙක් එක්කන් යන්න ඕනේ එතකොට. එක කෑමයක් retain වෙනවා. ඒ කියන්නේ අපි දැන් dishes තුනක් තියෙනවා ඈ. මේක තේරුණා නේද? Okay. Then it's fine. Right. Right. So one is becoming limited. Right? One is right? Yeah. Okay. Right. So you have to write it. Find the rate of reaction using reactant AB and products CD separately in the above reaction, assuming that the time elapsed is 0.1 second. So the time is 0.1 second. using A, B, C and D, write down the formula and the values and get the answers quickly. Using these values, you have to fill the table. Formula එකත් ලියන්න. Format එක R B ද R A ද එහෙම ලියලා ලියන්න. You will see something in the rate of reactions. I told you before that there is misconception that the people think the rate of reaction of one reaction should be equal for all the products and reactants. It's not. You'll understand it when you find the rate of reactions in those. Now, when ban taggala number of moles linga concentration 9 moles linga delta N over delta T. Finish? Oh, again, final value plus value at the end. Finish? Shall I start? Yeah. So the using finish? I'm going to write. So the using reactant A, that is Ra equals minus delta Na divided by delta T, right? Delta Na divided by delta T, and tell me the values. There should be minus in the front, minus delta Na divided by delta T. Now tell me the values. The final is 0 and the initial is 1. So it's 0 minus 1 divided by time is 1 second. So the rate is how much? That is 1 mole per second, right? That is the rate of reaction. And considering the B, that is Rb equals minus delta Nb divided by delta T, right? And tell me the values. Minus, final is 0.5, the initial is 1, that is 0.5 minus 1 mole divided by time is 1 second, and the rate is how much? 0.5 mole per second, right? 0.5 mole per second. And using product C, that is Rc equals delta Nc divided by delta T, yes. And the number of moles of C, the final is 1, initial is 0. So final minus initial divided by time is 1 second, mole. This is 1 second. So the answer is how much? 1 mole per second, right? And the Rd, if I take Rd is delta N D divided by delta T, right? And number of moles of, you tell me the values here. The final is 0.5 and the initial is 0, right? 0.5 minus 0 mole divided by the time is 1 second, and the answer is 0.5 moles per second. Now do you see a difference now? What is the difference? Not all the rates are same, yeah, so there is a difference, but some of the rates are equal and some of the rates are equal as well, right? These two are equal. Exactly, that is the reason, right? That was the point I was going to come, right? So these rates, like if you consider these rates which are equal, they have the same stoichiometry, right? If I consider the Ra and Rc, that is A and C, they have the same stoichiometry. And if I consider the B and D, look at B and D, their stoichiometry also equal. So the same stoichiometry have the same rate of reaction, get it? And when the stoichiometry changes, the rate of reaction also, that is the point, right? So the rate of reaction, is it depending on the stoichiometry? Is the, yeah, it is, right? As you can see, it changed, right? Yeah. So the rate of reaction is depending on the stoichiometry, that is one point. And if the stoichiometry are equal, the rate of reaction are also equal. And if it is a multiplication of the stoichiometry, is equal to another amount of either react, like let's say now listen, if I compare A and B, right? If I compare A and B, the stoichiometry is A and B is 1:2, right? And do you see the rate of reaction is also 1:2, which means 2 times the B, right? So the rate of reaction and the stoichiometry have sort of a relationship in that way as well. If the stoichiometry is 1:2, the rate of reaction is also 1:2. Get it? So those points you have to understand and keep it in mind, because when it comes to the questions you have to answer it correctly, right? So the stoichiometry changes the rate of reaction, right? And if the stoichiometry are equal, the rate of reaction are equal, and the rate of reaction is also in the ratio of stoichiometry, right? Get it? Right. So that's all. Like people online, did you understand up to that? And did you answer all these rate of reactions? Got it? You have to take it into your understanding. That is the very, yeah, understood it? Yes. Good. Shanal, yes? All good, right? Right. If you didn't understand any of the things, you can just tell me, so can do the honors of repeating it. Doesn't matter. Right? So, yeah, it's all good. Shall we come to this one? Yeah. Right. Methane gas combustion, right? And this is something about the limiting factor, and we discussed it already, right? A limiting factor. Right. Come to the methane gas burns with O2 to produce carbon dioxide and water, right? If 2 moles of CH4 and 2 moles of O2, this is supposed to be O2, supposed to be O2, O2 are present at the beginning, write the quantities that react and the quantities that at the end, right? So now this is methane gas burns with O2 to produce carbon dioxide and water, and this is the reaction, right? CH4 reacting with oxygen to produce carbon dioxide plus water, and the stoichiometric ratio is 1 to 2 to 1 to 2, right? That is the stoichiometric ratio, 1 to 2 to 1 to 2, right? So shall we write down the values that are reacting and the products, amounts of products that are producing? Yeah. So at the start there is 1 mole of O2 and there is 2 mole of CH4, right? 1 mole of O2 and 2 moles of CH4. Finish. So how do you do it? The stoichiometric ratio is 2 to 1, 2 to 1. So 1 mole of O2 are there and 2 moles of CH4 are there. So 1 to 2 should be reacting, right? sorry,
1 to
yeah, 2 to 1. So 1 to
1.
bro, 2 to 1 are reacting. So 1 to, that is something like this. Simple. Achcharata mechchara nan, yeah, that's all. So that is achcharata kochcharada
1.
mechcharai. Achcharata mechcharai. That is a stoichiometric ratio. Achcharata mechcharai. You have to find. So how much? That is 0.5. So 0.5 only reacting here. Get it? Achcharata mechchara nan, mechcharata kochcharada. So 0.5 is reacting. So out of 2 moles, only 0.5 moles are reacting. But out of 1 mole of O2, 1 mole is completely reacting. Get it? මේක 0.5 react කරන්නේ, right? 2 to 1 ratio එක. And how much is this producing? 1 to 1. How much is reacting? 0.5 is reacting, right? එතකොට ඔයා 2 නෙමෙයි consider කරන්නේ. React කරන amount එක 0.5 is reacting. So 0.5 is produced. If you consider this one, 2 to 1, 1 reacting, achcharata mechcharai, 2 to 1, 1 to 0.5. It does say H2O, 1 to 2, 0.5 to how much? 1 to 2, 0.5 to what? 1 to 2 reacting, 0.5 to 1, right? And 2 to 2, that is 1 to 1. 1 reacting and 1 produced, right? කොහෙන් ගත්තත් ඒක ඒ විදිහටම එනවා. ස්ටොයිකියොමෙට්‍රික් අපිට ඕන තැනකින් ගන්න පුළුවන්. You get the same answer. Yeah. And final amounts, 1.5 of CH4 is left without reacting. That is incomplete combustion. Complete oxygen moles are reacted, 0 left there. 0.5 here is produced. And 1 mole of this is produced. Got it? 1 mole of that is produced. Yeah, good. So that's it. You understood how the stoichiometry works now, right? So you're supposed to put the values likewise if one or two of the values were given. Can do? Let's see. Right. Right. So if the elapsed time is 1 second, write the rate of reaction of those above top values. Can you fast? Do it really faster. Now online people, you're all fine, right? With so far what we discussed. Yeah, good. Yes. උඩ තියෙන එක values ටික. ඉතින් values ටික ලිව්වේ නැද්ද? කොලේ හරවන්න ඕනේ. Is it same for the equivalent tute එක තියෙනවනේ? Even online people have the tute නේ. So මේක ගන්නවා. මේක දිහා බලාගෙන අරක fill කරන්න. But sometimes the paper gives the same way. Table එක හැබැයි answers අනිකුත් එහෙමද? ඔව් එහෙම බෑ. So the paper එකට ආවම පස්සේ උවිත හපන් එහෙම උවිත හපන් වෙනවා එපා වෙන જાති ඒවා. අනිත් පැත්ත තියෙන්නේ මතක තියාගෙන යන්න ඕනේ එහා පැත්තට. ඇයි ඉතින් නැත්තම් කොලේ පෙල්ලුවාම පස්සේ මතක තියන් යන්න එපා උත්තරේ ලියන්න. එහෙම වෙලා නැද්ද පේපර් එකකට? බයින්ඩ් බයි එල්වස්වලදී එහෙම වෙනවා. එහෙම වෙනවා. එහා පැත්තේ තියෙන එක මතක තියාගෙන යන්න ඕන ලියන්න. Yeah. Shall we check? So the right. So that is RCH4. We have to find RCH4, rate of combustion of CH4 equals minus delta N වලින් දීලා තිබ්බනේ. Delta N CH4 divided by delta T. Now tell me the values. Final 1.5 minus 2 moles and the time is 1 second, right? And the rate is 0.5 mole per second. And O2 RO2 is equal to minus delta N O2 divided by delta T, and that is minus, final value is 0 minus 1 mole, time is 1 second, so the rate is 1 mole per second, right? And products RCO2 delta NCO2 divided by delta T. What is the final? 0.5 minus 0. Okay, divide by 1 second, that is 0.5 mole per second, right? Yes, nice. And this one? R rate of formation of H2O equals delta NH2O divided by delta T. Tell me the final and initial values. 0 is it? Is the product? No. 1 minus 0. Right? 1 minus 0. That is 1 minus 0 moles divided by time is 1 second. So the rate is 1 mole per second, and as it happened in the last one, the rates are different, and when the stoichiometry are equal, equal, and the ratio of the stoichiometry and the rate of reaction are equal, right? Yeah, online people, did you got this? The same answers? Hopefully, yes. Yeah, good. Right. So according to the above calculations, the rate of reaction varies depending on the stoichiometry ratio of the reaction. Yes. Yeah. So if the rate of reaction is negative, it is rate of consumption of a reaction. Yes. Right. Okay. Exercise 1. Do the first 2 questions, right? First 2 questions quickly. These 2 are easy. Yeah. Just check doing it, it's easy. But you have to write the formulas, huh? Get used to write the formulas and no, mole per liter. Yeah. Mole per liter දීලා තියෙන්නේ. ඒ කියන්නේ ලීටර් කියන්නේ ඔව් concentration. මේ තියෙන ඔව් concentration ඔව්. ඔව්. ඔය තියෙන concentration එක. ඒ ඩෙසිමීටරම තමයි. ලීටර් කියන්නේ 1 liter කියන්නේ 1 decimeter. 1 liter equals 1 decimeter. ඔව් ඔව්. MOL L minus 1. Yes, divide කියන එක කියන්නේ. Hmm. Oh, oh. Minus answer ගන්න. මෙහෙමයි rate of consumption of කියලා තිබ්බොතින් හරිනම් ප්ලස් ආන්සර් එක තමයි හරි. මොකද රේට් එකට මයිනස් වැලියුස් නැහැ. ප්ලස් එක මයිනස් එකම එකේ තියෙන්නේ. එහෙනම් ප්ලස් එක ගන්න. No issues. Plus එක ගන්න. නේ? Because rate of reaction doesn't have any of the minus values. It's always plus. Rate of reaction is a plus value. Doesn't have to be minus. Got the answers? Finish? Right. So, what is the answer for the first question now? The question is the following reaction, the initial concentration of A, which was 2 moles per liter, was converted to 50% in 30 minutes, right? What is the rate of production of B? They are asking for the rate of production of B, and they have given the concentration of A. Get it? Concentration of A is given, they are asking for the rate of reaction of B. So what is the formula here? So if I found the rate of reaction of RA, there is a delta concentration difference of A. Is it the reactant? Ah, yeah, A is reactant. So minus delta T is the formula, and you have to apply it. So the initial is how much? 2 moles per liter, which is 2 moles per cubic decimeter, and the final should be half of it, right? Because only 50% is converting. So the final is 1 mole per cubic decimeter, and the initial is 2 mole per cubic decimeter, and the time spent is given in minutes, and even the answers are there in minutes. So you don't have to convert it into seconds, right? And you have to divide this by 30 minutes, right? So you have to multiply this by minus because it's the reactants. So what is the answer? 0.03 moles per decimeter per minute. 0.063 දාවේ. right. එතකොට RA වල වැලියු එක කීයද එන්නේ? RA වල එන්නේ මෙතන කීයද? මේකේ වැලියු එක එන්නේ 0.03. 0.03 mole per decimeter per minute කියලා තමයි ඉන්නේ. හරිද? හැබැයි අපෙන් අහන්නේ කාගේද? B ගේ. අපි දන්නවා ඒ දෙන්නගේ ratio එක 1:2. That means it has to be 2 times the rate of A. නේ B වල rate එක 2 times the rate of A. Yes. So the answer is fourth answer, right? Yeah, 0.06 mole per decimeter per minute, right? ඒකොන්නම් අපිට අර concentration එකකින්ම apply කරගන්නත් පුළුවන්. ඒ කියන්නේ මෙයාගේ 1 mole react කරනවා නම් මෙයාගේ කොච්චරක් හැදෙනවද? 2 moles හැදෙන්න ඕන නේ. එතකොට මේක ඇත්තටම 1 mole නේ react කරන්නේ. ඒ කියන්නේ concentration එක 1 mole per cubic decimeter තමයි මෙයාගේ react කරන්නේ. එතකොට මෙයාගේ හදනවා 2 mole. ඒක time එකෙන් බෙදුවා නම් හරි. එතකොට මෙතන බෙදෙන්න ඕන 2 mole divide by 30. 2 mole per cubic decimeter divide by 30. එහෙම ගන්නත් පුළුවන්. නැත්තම් මේක අරගෙන මේක stoichiometry එක බලලා double කරගත්තා නම් ඒත් හරි. කොහොමද understanding එක තමයි ඕන. කොහෙන් ගත්තත් ගැටලුවක් නැහැ. answer එක හරි. Online people, have you had the correct answer and did you understand the basis? Yeah. What happened to you? Fine. And it's difficult. Amari? No.
I was stuck in the second one.
Doesn't matter. Guys, is this fine? First one? Online people? Yeah? Hope yes. Yes. So the second question, the decomposition of KClO3 is shown in the following reaction. KClO3 converts into 2KCl plus 3O2. A sample of heated KClO3 produces 5 moles of oxygen in the first 5 minutes. In the next 5 minutes, 3 moles of oxygen were produced. The average decomposition rate of KClO3 during the 10%, right? Did you find it? Fourth answer? What do you say? No idea. Online people, what is the answer for the second question? The decomposition of KClO3 is shown in the following reaction, right? A sample heated KClO3 produces 5 moles of oxygen in the first 5 minutes. So they are given the rates, like the information to find the rate of formation of oxygen, and they are finally asking for the rate of consumption of KClO3, ne? Potassium chlorate. There is one of the hypochlorates which is used to clean the surfaces. Huh? Yeah, sort of a cleaner, right? And right, so we'll find the rate of formation of O2. RO2 equals, the values are given in moles, right? So it's delta N, and it's a production, so minus value doesn't have to apply. So delta NO2 divided by delta T is the formula. So now tell me the values. It says 5 moles of oxygen produced in 5 minutes. In the next 5 minutes, 3 more moles. So altogether, how many moles? 8 moles, right? 8 moles of oxygen are produced in a time of 10 minutes, right? So this is the rate of reaction of formation of oxygen. Yes. So it's 0.8 moles per minute, and they are asking for the rate of what? They are asking for the rate of consumption of KClO3. What do you do now? You consider the stoichiometry. Yes. So what is the stoichiometry? 3:2, right? Oxygen and KClO3 stoichiometry is 3:2. ඒ කියන්නේ අච්චරට මෙච්චරයි. You have to find මෙච්චරට, that's all. So you have to multiply this by අච්චරට මෙච්චර නම් මෙච්චරට කොච්චර, that's all, right? 3:2 ආට හොයන්න තියෙන්නේ මෙච්චරට. So you divide it, what do you get? You did 0.8 into 2 divided by 3. Same answer. Fourth answer. Whatever. Moles වලින් ගිහිල්ලා ගත්තේ. ඒ කියන්නේ rate එකට එන්න කලින් react කරන 16 divided by 16 divided by
3.
Okay, and 16 is what?
16
I can make a amount එක ඔයා ගත්තද? ඒ කියන්නේ amount එක මුලින්ම KCl3 amount එක ගත්තද? එතකොට 8 moles වලින් okay. Right. එහෙම ගන්න පුළුවන්. ඒ කියන්නේ මුලින්ම O2 වල amount එක අරගෙන O2 amount එකෙන් ඔයාලට KClO3 amount එක ගන්න පුළුවන්. ඒක stoichiometry එකෙන් ගත හැකි. ඊට පස්සේ time එකෙන් divide කරන්න තියෙන්නේ. Same thing. ඒක අවුලන්නේ. whatever. Half away until which point? මෙතන දැන් ආවා. ඊට පස්සේ මේකට ආවේ නැහැ. Doesn't matter. Online people, did you answer it by yourself, or what happened? Answer it correctly, or at least like the first thing is the did you understand it or not? Yeah, you understood it. Yeah, only a matter of application. Yeah. Take it into brain and you have to put it back into the paper. That is something will take a little time, but now you have the question bank 2. Follow it. It'll be fine, right? Online people, did you do it correctly? Understood it? What happened? Anybody? Understood it? Yes. Shina, good. Shiny, what happened? Malshi? Understood it? Understood. Good. Nice. I hope the Malshi is the same. Right. So this is homework. You do this at home. This is homework. Question number 3 homework. Mark it. Right. The next thing is finding the average rate, right? Average rate of reaction. So shall we start this the next week, because average rate of reaction is something to discuss, and hopefully after the average rate of reaction what we have to do is a bit of a theory is there. and after that we can finish the rate of reaction as well. So now this part, average rate of reaction, I'll give a bit of a clue what average rate of reaction is. Now you understood that the rate of reaction is changing when the stoichiometry is changing. And what if we want to have a sort of a same rate for each and every reactants and the products? If you wanted to have the same rate for each and every reactant and the products, you have to get rid of the impact of the stoichiometry, right? Because of the impact of the stoichiometry, the rate of reactions were different, right? So you have to cancel it out. How do you cancel it out, the effect of the stoichiometry? Can you think a bit? This is very simple when it comes to the formulas. Like I'm just trying to brainstorm. So now this is the thing. If I want to have the same rates for each and every reactants and the products, right? And what should I do now to have the same rate for all the reactants and the products? Hmm. ඒක කොමන් වෙන්න ඕන හැම එකකටම. මේකට යන්නකෝ. මේකට යන්නකෝ. දැන් මේ වගේ values වෙනස්නේ. And you know the stoichiometry as well නේ. මේකේ පේන්නේ stoichiometry එකේ පේන එකට මේකේ පේනව නේද? මේකට එන්නකෝ. දැන් මේකේ 1 1 0.5 0.5. දැන් මට මේක එකකට ගන්න ඕන නම් ඒ කියන්නේ equal rate එකකට ගන්න ඕන නම් හැම එකේම මට stoichiometric effect එක අයින් කරන්න වෙනවා නේ. මොකද stoichiometric effect එකකින් හින්දානේ values වෙනස් වුනේ. මං අහන්නේ කොහොමද මම stoichiometric effect එක අයින් කරන්නේ? Bit of a brainstorming. Right? Think of it at home. We'll discuss it the next week. Right? ඒක හිතන්න. ඒ කියන්නේ මට ඕන මේ ඔක්කොටම එක common rate එකක්. හරිද? එක rate එකක්. එතකොට stoichiometric effect එකකින් තමයි rates වෙනස් වෙලා තියෙන්නේ. කොහොමද stoichiometric effect එක අයින් කරන්නේ? Rate of reaction එක ලියනකොට. Huh? Yeah. Yes. So come up with an idea the next week. We'll discuss it anyways. Right. So people online, think of it. We will discuss it the next week and do the homework. You have the question bank. Go through the questions before you forget all the theory. Thermodynamics questions එකේම කරන්න ඉවර කරන්න. ඊට පස්සේ kinetics එකෙත් මේකට අදාළ ටික කරගන්න පුළුවන්ද? ඊට පස්සේ theory questions theories ටික තමයි discuss කරන්න තියෙන්නේ. Average rate of reaction එකෙන් ඇත්තටම calculation එක ඉවරයි. ඊට පස්සේ theories discuss කරන්න තියෙන්නේ. theories ටික හොඳට ඔලුවට දාගන්න තියෙන්නේ. ඒක කරගන්න පුළුවන් ලේසියි. Right? Okay. So then, adios.